Hi class, today we'll be covering chapter 1, Introduction to Computer Networks and Data Communication. Alright, um, basically as soon as we complete this chapter, I think you have a basic understanding of some of the terms that they use in the network. You have a overall big picture of how the computer networks looks like, and there'll be some example, and also some of the reason of why the network architecture is created like that. Okay. Also, we will take a look at TCP/IP, which is transmission control protocol. It's basically the process of the signal. How is it being transmitted when somebody, for example, requests a website, or could be sending an email or text message, things like that. And also we be looking at the OSI model, and also some comparison between the two, right? Okay. Let's jump into introduction. Okay, the question is, who today has not used a computer network? I think pretty much uh, we are using it right now, uh, as we speak. um, and we do take for granted, but we only realize it when the network is down, as compared to in the olden days. Okay, later we'll take a look about the technology in olden days. We see technology today, especially networking, in, for example, in the mass transit. Okay, it could be your e-commerce, could be at Walmart, could be the things that you are watching Netflix, and pretty much part of our daily life, right? As for the computer languages, right? Um, as we speak, basically the computer network, over here they explain, is interconnection of computer and computing equipment using either wires or radio wave. Okay, the desktop, your notebook, your laptop, uh, connected by wires and even wireless too. Okay, and your mobile devices are wireless. Even your smartwatch, okay, Fitbit, right? Next is LAN, which is what we call a local area network. Uh, you can find local area network in a small setting, like in a small office, with a few computer printers. Yeah. Um, Next we have metropolitan area network, uh, which is pretty much a small city, where they provide network access within the city. This is to basically to promote fast information of, it could be upcoming event, um, news. It's another form of marketing to around the area to let uh, business grow around the area. Next we have wide area network. Later we'll cover that in the class, the next few slides. Wide area network is more like a bigger area, like the state, or they call it WAN. Okay. Also we have personal area network. It could be within a few meters. Usually these are wireless, right? In some countries they have wireless devices, let's say to check for parking meters, things like that. Also we have the campus area network, typically like SoundCloud, right? It's a campus wide, and student can connect through wireless network quickly. All right. Next we will take a look at also the languages, which for example the first one is data communication, where digital or analog signal are being used, okay, to transfer. Digital, as you know, is binary 1 and 0, and analog is basically sine wave, right? Telecommunication, here is a study of how the telephone works, through transmitting signal, especially voice, right? Network management is basically, prior to setting up the network, you must be able to design it. Okay? The number of users you need to know, how many printers are there that, for example, the office need, and how big is the office, and that's where you need to manage the hardware and also the software. And today we have also cloud, okay, where most data are being uploaded by the server, and you can access remotely from anywhere. Right? For the big picture, to summarize it, we have the workstation, uh, the PC, your tablet, your mobile, are being connected to the server, and from there to the network switches, so that it could be routed, okay, from LAN to WAN to WAN, right? From a smaller area to a big wider area. Okay. Also network nodes and sub network. Okay. Next, take a look at a picture of an example. Like over here at figure 1.1, we can see user A, which is top left hand corner. He's technically is in wide area network 1, and he, let's say he's trying to communicate to the person below. By him sending the signal has to travel from the PC to the modem to WAN 1 and across the router. This could be an example like in Walmart. The guy working in Walmart is trying to send an email from, for example, SoundCloud to the headquarters, and the signal from user A will move from the workstation to the modem to the WAN and across the router to another, could be interstate, and it will reach the LAN area. Okay. In this case, for example, the headquarters is in SoundCloud too. So it could be nearby, and once it reaches LAN 1, the signal will pass through the switch and down to the person with the PDA, for example. And this could be the person checking the number of stocks for a customer, for example. Some common example: desktop computer, okay, and the internet, right? This is basically a network example. Okay, your laptop, your wireless connection, your cell phone, which is your mobile device. A new thing like industrial sensor, we take a look at it, and it's more based on a factory line where production are being assembled as the product move through the process, and with that it will trigger certain process. For example, assembly of cars, it could be semiconductor factory. Okay. Next, also we take a look at mainframe. Mainframe are basically huge networks where the process, it could be saving your data too, right? And also satellite and microwave, where signal are being transmitted across countries. Some example of network communication. Okay, you look at the picture here. We have this lady, right? So on a typical office setting, we have the desktop, right? And she will be doing her work, and at the same time the laptop is there, and she could be surfing on the Facebook or something else, and on the cell phone she could be chatting with her friends, or uh, TikTok. Oh, probably, yeah, TikTok is not here, it's banned apparently. See, so these are some of the common network devices that we have around us. Okay. So where you can find this, right? Like we mentioned earlier, okay, in companies, right, in schools, at home, okay. In terms of speed, medium to high, it depends. If, for example, in Singapore, the higher you pay, the faster you go, right? And in order to do that, you need to have a modem, which is technically a network interface card. Today, most modem are already embedded inside the PC, for example, or in your laptop. Okay, right? And from your modem, from your NIC, uh, you could connect directly to the switch. Okay, right. Let's take a look at the next figure. Right, like we mentioned earlier, we have the two workstation there, and we have the cable that is connected. It could be RJ45. It's like a phone cable, but it's much thicker. And from there, the cable is travel up to the switches, right? So the common connectivity in school, we have the Ethernet, right? Right, and in the olden days, at home, people use dial-up. Dial-up is essentially the first type of modem, which the speed is about 56.6 kilobyte. Essentially, it's using the telephone line as a way to connect to the internet. And the disadvantage of using dial-up is if you have only one phone line, okay, nobody could call you in if you are using the internet. Okay, so if you want to use the phone and the internet for your computer, you need to have two phone line. Okay, and they call it dial-up is because it has a ringing tone, and the modem will dial a number first in order to connect, and from there you are able to connect to the internet once it's connected. Okay, clear so far, right? Also, we have a DSL line, or you call it a digital subscriber line today, right? Which is more modern. It's much faster, and today we have fiber optics. Oops. Which is glass, and it transmits light, and these are much more powerful and more reliable in terms of signal processing. Okay. Okay. Over here we see on the figure, essentially a workstation is connected to the network, and there's cable which also connect to the modem, and from there the signal will travel to the internet service provider. In this case, for example, it could be if you are using I don't know, like in the olden days you have AOL for your internet connection. Okay? And from there it will route use and also get into the internet. Okay? So at school here they mentioned that today we are connected through wireless or Wi-Fi, right? And most routers are wireless, right? It's technically plug and play. And not forgetting the wireless router are connected via wire to the network. Okay, and here we have a typical local area network, which is LAN A and B, right? And they are both connected to a different hub, and in order to communicate, they are required to connect to a switch. Okay, let's take a look at the cellular market. Yeah, especially in the States, with the high demand of wireless or mobile phone, uh, things are growing, and technology are advancing, from GSM, uh, also CDMA, right? Uh, and now GPRS, things like that. Okay. Previously we have the 3G, and now we are using 4G, fourth generation technology, and sometimes you have the LTE, and now I think we heard about 5G, between Donald Trump and China. See, that's 5G, which are trying to control the market, right? And Here you see the example, the speed is increasing from 100 second to 1000 second kilobytes. Right? The next slide we'll take a look is the cellular network. A typical cellular network will have a tower. This will transmit and receive cellular signal from your phone as you travel. I think some of us do have experience signal bar or the signal being cut off while we travel in a car along the road. Most of these cellular network are spaced apart, like social distance, and each cellular network will overlap, and depends on the geographical. There are some gaps in between, and uh, today technology is there for us to able to connect quite efficiently, and you can see that in your phone as the level of signal is there from 1 bar, 2 bar, 3 bar, or 4 bar. Okay. Next we take a look at industrial sensor. Essentially it's not a local area network, and it can be found in factory style or environment, okay, in a assembly line, for example. We take a look at the picture. Here we have like a car assembly. So on a automation line, for example, assembling a car, once the car passes a certain point or a sensor, it will trigger some certain process. For example, it could be assembling the hood of the car or the boot of the car, or it could be welding the car, or it could be painting the car. Right? Next, we take a look at the mainframe. Mainframe are a legacy system. What I mean is prehistoric. One of the first few computers. Most of these computers are as big as a house. It could be, and they run by using card system, and each calculation are being meticulously processed in such a way that some of them are being operated manually by putting certain disk drive, which is a physical disk drive, and also manual card. Okay. Apparently, some of this mainframe systems do exist, uh, because of the data that they have, and due to some company they are reluctant to upgrade the system, um, so it's still there. Okay. Also we will have like telnet, okay, which is local area network, provide bidirectional interactive text oriented communication facilities. And also we have thin client. Thin client is essentially, for example, we have a keyboard and just a monitor, and in order to access, for example, the internet, the cable is connected through the system directly. Okay. Later we take a look at some a picture example, right? Okay, the next one is basically a thin client. Okay, here we see, like I mentioned initially, the user only have a keyboard and a screen, and the screen is connected to the mainframe. Okay. So next is satellite and microwave. So to communicate over long distance, satellite are used. A person from, for example, in Singapore wants to send a message or talk to somebody somewhere in America, and signals are being transmitted via the satellite. Okay, and it could be phone call, television, things like that. Could be a Netflix, or digital radio. Right? Because of the complexity of this technology, there's a price that we have to pay. It's rather expensive, and most companies don't provide that unless you're willing to pay a high price. Which most of this technology are being used by the military. We have the satellite phone, for example, in order to communicate. It could be in the middle of the jungle, or in the middle of the desert, or in the middle of the sea, right? But having said that, today we do have WiMAX, which is essentially a newer technology, which could be connected quite a short distance. Okay. Here we have the satellite and microwave network, right? For example, a TV company wants to transmit its signal over houses or businesses. It uses the satellite. A fine example of satellite is Walmart, where they invested in technology, especially in the data warehousing facilities, where they could track the number of goods that being sold. And with that, because they had all the data quickly, they even had their own satellite in order to process the real-time information. And from there, they could predict the most selling item, and they could replenish the stock quickly, and management are able to make decision there and then. As for next, we take a look at network architecture. This is more detail. Okay. Okay, we have a model, which are the layers. Okay. What I like to focus now is more on two things, which is the TCP/IP protocol suite and the OSI model. Uh, okay, the TCP/IP is basically a transmission control protocol or slash internet protocol, and the OSI model is a open system interconnection model. Okay, let's take a look at the graph, not graph, the figure. Here we have the TCP/IP. We have 5 layers. Okay, the first one is application. Next, we have the transport. The third one, we have the network. The fourth one, we have the network access. And number 5th is the physical area. Okay. To take a note that some authors will show only 4 layers combining the 2 bottom layer. Alright. Essentially they are combining the network access layer and the physical layer. Okay. But don't worry about that. Okay. So let me explain to you about the layers. In the TCP/IP we have the application layer. Basically, for example, when a user wants to email or surf the net, that is the first layer where they have to go through. Okay. The next layer is the transport layer, where after putting in the website address, okay, the website address is being transported, okay, over the network in order in the form of package, okay, in order to the sender to receive it, right. From the transport layer we have the network layer, which is the internet. Okay, here the network will create, essentially maintain also the connection. For example, from end to end, which is the router. Okay, as it moves down, we have the network access layer, which is data link layer. Essentially, is taking the data and transforming it into a frame. Okay, later we see some example where we have categories or segment where we call headers, control, and the address, and also error detection as the package move along the network. Okay. And lastly is the physical layer. This is technically the cable, for example, the hardware that is being used to send the data. Okay. Let's take a look at the figure, which shows much a clearer view. We have the user over here. For example, he wants to send an email. Okay, there the application layer, for in this case the application worker, okay, will create the message, and from there the transport worker will send the information over to the network worker. Okay, so from the message, okay, is using the transport, okay, over the network. Okay, and the fourth stage, okay, is the network access layer, okay, where, like I mentioned, the segment be included from headers to error detection, and with that combination the data is sent over the physical layer. Okay. On the next slide we'll take a look at the comparison between OSI and TCP/IP. Here you can see that on the OSI model, the application, presentation, and session layer are being combined to form the application layer in the TCP/IP. Okay, and the transport layer is the same, the network layer is the same, data link is similar with a different name, which is network access. As you can see here, the OSI level layers we have like 7, as compared to TCP/IP we have 5. Okay. So take a look at the OSI model. Similarly to the TCP/IP application is quite equivalent. Right? Next, followed by the presentation layer. Here, the data is being compressed or encrypted at the same time prior for it to be sent to the next layer, which is the session layer. Okay. And in the transport, is equivalent to TCP/IP. As for network layer, which is what you call it, the network access layer. Right? In the OSI model, we have the data link layer, which in this case includes the header, the information, and the data correction. And lastly, we have the physical layer, which are the cables. As for logical and physical connection, okay, the logical are basically the software, and physical are basically the hardware. And as the data flow from top to bottom in the network architecture, basically the lowest layer is always the physical layer. Okay. Over here we see how they are categorized. Okay. On the left side, for example, if you want to send the signal from, for example, the sender, the data will flow from an application layer on the left side down to the transport, down to the network, down to the access layer, network access layer, and to the physical layer, which is the wire or the cable. And once it receives over to the receiver, okay, the data will be desegmented, okay, and it will move up from the physical layer to network access, to network transport, and to the application where the receiver get the message. Okay. The next slide we will see the types of header and error detection. Oh, yeah. Okay, mine. Okay. Just before we go that, we have this a typical setting, for example, in an office where how two deans are communicating, where information are flow from the dean to the chairperson, and the committee to the secretary, and then from the secretary to the other secretary, from the art science to the school of business, and from the secretary up to the committee, marketing committee, up to the chairperson, marketing, and up to the dean of business. Okay, right? Okay. See? So now we have a clearer view of the TCP/IP. Okay, on the top left hand side, for example, a user wants to get to a website. Once putting in the URL or HTML, from the user side, the signal will flow down over the transport layer where we have the header for TCP, okay, which is the transmission. Okay, and from there, the signal will move down over to the network layer with the internet protocol are being added in front of the TCP header, and as it moves down further down on the network access layer, they will add a LAN header on the front and at the back. Okay. And because it's a TCP model, so we only have 5 layers, which is the local area network, which is the physical layer, which is the cable, and it will send over on the right side. And with this package, okay, on the top you see the local router will be able to recognize, okay, the IP header, the TCP header, and the website, and essentially it will send it to the appropriate, in this case, wide area network. Okay. And as it moves along the wide area network, okay, every segment is being recognized, okay, all the way until it will be desegmented over the web server, in order to get the website. And take note that this process is really fast. Okay. As we look at the internet, okay, most of these calculations are being done quickly. And alright, so that's pretty much it. If you have any question, feel free to email me or request for appointment. Okay, alright, thank you. Be safe.